Assalamualaikum warahmatullahi wabarakatuh. My name is Difa Ardiensyah, Chemical Technology 20 and 21. In this video, it's about thermocouple. And get your coffee and let's get started. Thermocouple. In the world of electronics, thermocouples are temperature sensors that are widely used to convert temperature differences in objects into change in electrical voltage. A simple thermocouple can be installed and has the same standard connector type and can measure temperatures within a considerable temperature range with a measurement error limit of less than 1 degree Celsius. The reading is done with a multitester or avometer. It serves as a low and high temperature sensors. Temperatures as low as 300 degree Fahrenheit to high temperatures used in industrial process of steel, glass, and ceramics that are over 3 million degree Fahrenheit. Thermocouple is formed from two different types of delivery, iron and content, and wrapped together. Working principles. If one of the base of the winding is radiated, then at the both ends of the delivery, the others will appear a potential difference or EMF. Thermocouple was discovered by Thomas Johann Seebeck in 1820 and is known as the Seebeck effect. A Seebeck effect. A simple thermocouple circuit is formed by two different types of delivers, iron and constant, wrapped together. One end of the T is the measuring junction and the other end as the reference junction. Reference junction are kept at a constant temperature of 320 Fahrenheit OOC or 680 Fahrenheit or 200 Celsius. If the Tn is heat until there is temperature difference against the Tr difference the Tr and combination of the type of delivery metal used determines the linear characteristic of the temperature to voltage. Types of thermocouple delivering metal combination. Type A chromal constant, type J iron constant, type K chromal aluminum, type R as platinum rhodium, type 3 copper constant. The output voltage of the thermocouple EMF is still very low, only a few millivolts. Thermocouple work based on difference in measurement. Therefore, if you are to measure an unknown temperature, you must first know the VC voltage at the reference temperature. When the thermocouple are used to measure high temperatures, a voltage of 10 will appear as large as a VH. The real voltage is the difference between VC and VH called net voltage or Vnet. The magnitude of Vnet is determined by the formula. Vnet is thermocouple output voltage. VH is voltage measured at the high temperatures. VC is reference voltage. A thermocouple consists of two pieces of dissimilar metals with their ends joined together by twisting, soldering, or welding. When heat is applied to the junction, a voltage in the range of millivolts is generated. A thermocouple is tempered. Sorry, a thermocouple is therefore said to be self-powered. Shown in the figure 3 is a complete thermocouple circuit. The voltage generated at each junction depends on the junction temperature. If temperature T1 is higher than T2, then the voltage generated at the junction 1 will be higher than our junction 2. In the above circuit, the loop current shown on the galvanometer depends on the relative magnitude of the voltage at the two junctions. In order to use the thermocouple to measure process temperature, one end of the thermocouple has to be kept in the contact with the process, while the other end has to be kept at the con- constant temperature. The end that is the contact with the process is called the hot and measurement junction. The one that is kept at the constant temperature is called cold or reference junction. The relationship between total circuit voltage and the EMF at the junction is circuit EMF is measurement EMF means reference EMF. If the circuit EMF and reference EMF are known, measurement EMF can be calculated and the relative temperature determined. To convert the EMF generated by a thermocouple to the standard 4 by 20 milliampere signal or transmitter is needed. This kind of transmitter is called temperature transmitter. Figure 4 shows a simplified temperature transmitter connection. In figure 4 above, the temperature measurement circuit consists of the thermocouple connect directly of the temperature transmitter. The hot and cold junction can be located whatever required to measure the temperature difference between the two junctions. In most situations, we need to monitor the temperature rise of equipment to ensure the safe operation. Temperature is the rise of the device in operation temperature using ambient or room temperature as reference. To accomplish this, the hot junction is located in or on the device and the cold junction at the meter of transmitter as illustrated in figure 5. Here are the advantages and disadvantages of thermocouple. Advantage 1. Thermocouples are used on the mass transformers. The hot junction is inside the transformers oil and the cold junction at the meter mode of the outside. With this simple and rugged installation, the meter directly reads the temperature rise of oil above the ambient temperature of the location. 2. In general, thermocouples are used exclusively around the turbine hall because of their rugged construction and low cost. And 3. A thermocouple is capable of measuring a wider temperature range than an RTD. Disadvantage 1. If the thermocouple is located some distance away from The measuring device, expensive extension grade thermocouple wires of the compensating cable have to be used. 2. Thermocouples are not used in areas where high radiation fields are present. For example, in the reactor fault, radi- ra- radioactive radiation, like beta radiation from neutron activation, will induce a voltage in the thermocouple wires. Since the signal from thermocouple is also a voltage, the induced voltage will cause an error in the temperature transmitter output. 3. Thermocouples are slower in response than RTDs. And 4. If the control logic is remotely located and the temperature transmitter or millivolt to milliampere transducer are used, a power supply failure will of the course cause faulty reading. Thanks for watching this video. My name is Difa Ardiensyah. Goodbye and wassalamualaikum warahmatullahi wabarakatuh.